Hello everyone. So let's get started with the plan for this evening, morning, whatever. And so the idea is to keep the use case very simple. We start from the easiest pipeline in machine learning and data science that you can imagine. And then we go ahead and take a look at how Dagger can implement different kind of automation and reproducibility in terms of, okay, I have my results. I want to rerun this independently from the platform I'm in. So, or even eventually on a CI pipeline, for example. So let's dive in first of all to what is the main character today, that is Dagger, and let's taking really a quick sneaky peek to what we are expecting for today, for this evening. So the if you have not heard about Dagger, you can imagine that like an engine for running. Yeah, it's taught with CI/CD pipeline in general, so in mind, but it's quite a bit more to me. So it's like an engine that abstract away all your dependencies on your local machine and create really a self-contained sandbox where you can run in a declarative way a series of workflow steps. So without further ado, let's take a look of the main characteristics. So you add to dagger.io and you end up with some useful information. But let's start from this graphic here. We are letting things, let's say, a more far away from this perspective, but then we are going to go deep again into zooming into the right hand side, for example. So first thing first, we have an engine and we have description of our workflows that can be CIs, can be anything, but can be, in our use case, a data pipeline. So I have to import my data, to read and filter my data, and then eventually do machine learning and inference on the models that we create. So yeah, it's tough with CIs, but the challenge today is see how far we can go, considering this really a tool for uh, doing machine learning or data science in general. All right, so what is cool about this is that you don't have just an engine, you have a series of integration with languages that are so far Go, TypeScript, and Python. We are going to use the Python one, but please keep in mind that all these Lego blocks here are simple modules that can be reused independently from the pipeline you run. So we are going to write some modules today, but the very same modules will be adaptable to different use cases. And moreover, we also have use cases where you want to communicate with different languages. Modules in Dagger does that, and we will see it in practice. So you define a reusable piece of software that you can integrate in all the languages that are supported, so Go, TypeScript, and Python. An example, we are going to write modules in Python to import data from Kaggle, a dataset from Kaggle, and then you can use the very same module into a Go function. So you can create your Go code and run a function that is importing data via Kaggle using the module written in Python. That's huge, you can imagine. So, and this is everything thanks to the Dagger engine that we are going to look at just in a few seconds. All right, so the idea is this one. We are going to write down some modules, see how they run, starting from scratch. Really, I just installed on the machine. We are going to use the Dagger engine and the Docker engine. That's all you need. we don't need anything else. And so we start from scratch, produce our first function, and then adapt new function to the challenge that is reproducing a pipeline from a Kaggle notebook, basically. And okay, so let's start with the proposal. We are going to start from a Kaggle challenge, as I mentioned before, and yeah, so this is a typical challenge for entry level people in Kaggle. If you don't know what Kaggle is, you can head to Google and Google it. But it's basically a portal where different datasets and experts in data science and in machine learning are converging, and they are starting to play and challenge on different kind of activities, starting from tabular data until vision, machine learning on, let's say, images or whatever. So we are start simple, as I mentioned before. So we are take this data set, that is the Titanic disaster, trying to forecast the probability of survival of different people based on some statistics. And it's really the demo one, so we are going to take as simple as possible notebook and start from very few functions to be implemented, also for a reason of time. And then after we have studied the excuse that we are going to use to understand how Dagger can behave in this environment, we are going to set up 3 different functions. So the first one is importing data from Kaggle, and then there is the pre-process step. That means reading data and pre-processing it. Yeah, it can be as complicated as you want. We are going to do very few filter steps, so nothing particular, but this is our deck, if you want, starting from importing data, pre-processing it, and do machine learning. All right, so then we have to set some target for the challenge, right? So we want to achieve something that we can reproduce everywhere. So we want to put in place some piece of code that we can reuse not only for Titanic, but also for different challenges. And we also want to keep the freedom to develop further our models and to make and extend as needed. In other words, we're going to run Dagger functions and see how it works out. Just last step of introduction, I promise we are going to code very quickly, so bear with me. There are just few notions that I want to tell you. So we are going to have a Dagger CLI where we set all the commands to run different piece of our function, and where we can tune the parameters that we pass to this function. And then there is the Dagger engine on the other side. And the Dagger engine is basically a set of 2 main components. The core one, that are all the sandbox content, if you want, if you can imagine like that. So we are going to build containers into this sandbox. We are going to import data from the host into the Dagger engine. We are going to create cache files where everything will live inside the engine and will be independent from where we are running on our operating system. In fact, the Dagger engine will be a Docker container on our host. So there is this very important part of the implementation, that you should consider everything like separated from your host, right? So keep that in mind. You can import data, you can manage them some way, but this is meant to be an autonomous entity, right? And then you have your software that you can split in function that define a kind of what is called a module. So a set of instructions that can be chained, can be executed as they are, can create containers, can create services. We are going to dive gradually into each one of these. That's all. I mean, it's simple. In saying that, it's not so simple to understand everything from this graph. So this is the reason for which we start immediately from the documentation. And again, my attempt here is to start from scratch, so you see every single step that is needed to get started. And in my host, I just created a virtual machine, and I install, as I mentioned before, Docker and Dagger CLI. And the Dagger CLI is essentially this one. So we can start from Dagger version, and here is the engine. I already ran some examples, so the engine is already running. As I mentioned before, this is a simple container running on your host. Then you have the possibility to instantiate a Dagger example. So let's do that. I'm going to remove the one that I ran before. Oops. And I start from very simple example. So you do potato. Again, you go inside potato, and you see that there is a structure like that, where you have a source main with some code, a Dagger JSON where is the description of all your dependencies, and some code that is auto-generated, that is the one responsible of the abstraction of the functions. So, all right, then let's go into the Dagger folder and let's open the all right, let's open the src init. As you can tell, writing a function and a module in Dagger in Python, it's simple like this. So you will start with something initialized, and you are prompt with two main function of the class methods of the class potato that represent the actual Dagger function that you can run with a command line, for example. And in this example, you simply have a container echo. So you pass an argument that is called string arg, and that's done. So you will be prompt with the execution of a container in our Dagger engine that starts from an Alpine image and chain an execution of an echo command. Let's see this in practice. So we are here and we run. This is the syntax. So Dagger call container echo string arguments and hello Dagger nodes. And then we ask for the standard output. Let's see how it goes. Let me clear the screen and try, oops, and try again. All right, it will initialize the communication. It will take some time to connect to the GraphQL server and then execute what you ask for. And here we are entering the runtime. We're executing the container echo, and eventually the system responds with the expected output. All right, so the question now is how we can tweak this kind of example to produce something that is not a potato module. And to do that, we're going to set up a new a new Dagger module that we are going to call, I don't know, we can call it Dagger of Data Science. Kaggle Dagger. All right. So we're going to create this. And there is one thing that I suggest you to do when you want to develop with Dagger, that is essentially taking the Python SDK reference, no, the IDE integration, and set up with whatever package manager for Python you prefer. We are going to use the standard one, and set up this in order to have auto-completion for your IDE in turn. So, all right, we have now cargo Dagger. We're going into Dagger. Perfect. And then, all right. Now we want to do what's suggested here. So create a Python environment, virtual environment, and do these steps. So we have auto completion. Just a second, don't worry. I should have the 3.12 installed, so it should be good to go. Yeah, exactly. So I'm installing all the dependencies, and eventually, yes. Sorry about the noise. All right. So we have everything installed. We can go ahead and say, wow, nice, I'm src init.py, and here it is, my Dagger function. So Dagger container, and you can see that now I have auto completion that can help me a lot in doing what I need to do. Cool. So let's start from something very simple. We have a folder. Oops. Okay. So we have a folder that, come on, okay, where we want to put all our notebook information. So we want to start from an example. And so this is going to be called working dir. We're going to put here all the persistency that we want to achieve. So in this case, for instance, we're going to take the Titanic challenge. So Titanic challenge is this one. You have a lot of statistics where you want to do your machine learning to foresee which is the kind of probability of survival for the passenger of the Titanic. So we need, first of all, to download the data, and you can do that by installing the Kaggle CLI and download like that. So we are going to do this. All right, this is done. And then we are going into working directory. We're going to do make dir input just to store everything into the input directory. And all right, and then we do unzip working directory. Sorry, or unzip Titanic. All right, now we have here all our CSV. That is all we need. we miss one other thing, that is how we do this analysis. That is not the purpose of this session, so we're going to take something that has been provided by Joseph PNC for us for the Ego with a very basic implementation. So we are going to import data and do some preliminary printing of the datasets, and we do some also basics transformation to keep everything under control for the machine learning perspective. And eventually you define a training and a sample, and you do a model training and prediction. That's all. It's very basic. You can see that there is nothing particular. I just want to split this into 3 pieces that we are going to implement into a pipeline. Cool. So we need to download this, and if I remember, oh yeah, right. So I need to register first, and then I'm going to download download this. All right. Okay, so I downloaded that, and now we are ready to set up our first Dagger function. Are you ready? So we're going to src main. We're going to take out this function here. We are going to call this Jupyter Lab, and we are going also to string argument. That's okay. We're going, for example, to pass to our Jupyter Lab a sensible token, so for the access to the web UI, and this is supported by Dagger. If you go to the documentation, sorry for this back and forth here. So we create our function as mentioned in the documentation. You can take all your time to look at that. But again, Dagger hello world, Dagger nodes, okay, potato message. So we need to find, here it is, secrets. So you can pass as argument to the function not only strings or directory, as we will see, but also token that are Dagger secret. So going back to our terminal, we can say, okay, I want an argument that is a token, and I want it to be a secret, right? So the other cool thing about Dagger is this one. We can document every single step we do. We returns a container. No, this time is returns a service running a Jupyter Lab instance on working there. So the other one thing that we want to do, we are going to pass here working there as a directory, and then I want one more thing, that is to tell Dagger, all right, so Working directory is what I pass you. All right, sorry about that. Return Dagger. Let's clean this up. We have to put some things in chain. So okay, from we're going to use a minimal image for the notebook that for a Jupyter lab should be something like Jupyter lab quay image. Exactly. Yeah, so we can use this one, site by notebook. Here it is. So, all right. Let's start from this. Jupyter Lab, quay, oops, quay. Oh, come on. Okay, quay latest. Let's put this in this way. Then we need something else that is the following. We want to mount with mounted directory, and we want to mount in Jovian. So for instance, Jovian, that is the well-known user for the default image. So we are going to put our directory here where we find data and our notebook. The container will start with this mounted, and we also need to tell the directory, the source directory that we meant. So in this case, it's working there. And oh, oops, that's okay. And that's also one thing that you should remember, is that if the user is not the root one, you should also say, okay, this folder is owned by this user. We want that a service that expose a port on 888, that is the default one for Jupyter Lab. And okay, we could stop here, but we want this to be a service. A service is something that container that is running inside the engine, but in principle you can expose to the host. That is exactly what we want to do. We want to run a Jupyter Lab to see what is stored on the working directory of us and do some basic stuff. So please notice that this is not the target of our session today, but it's just to introduce how function works. Then, for instance, we can chain the import of the data with this kind of function. So you have a Jupyter Lab that starts and immediately download your data. That's one option, and we are going to see how it works. And then the other option is, all right, cool, now I can get rid of the Jupyter Lab and insert different kind of function one after the other, and we are going to see how it works, the chaining stuff, to do our pipeline, to reproduce what the Jupyter Lab is doing right now. With a main difference that now the pipeline that you do in a separate steps is reproducible and composable inside the engine, whatever engine, not only on your machine, but everywhere else. Okay, so cool. We need also to change this because, of course, the entry point for a Jupyter Lab notebook is not that, is notebook pi, and then we need to pass the option to start with a token. And we can do that with minus minus identity provider dot token equal token. So here it is. Okay, let's see why service is not found. Yeah, it's found. Okay, and then eventually, right, we need to say, okay, start this container as a service. So far so good. We can remove Dagger from here and we are ready to go. So we have our Jupyter Lab. Perfect. So let's see how it goes. We can now, let me clean here, call our fresh new function with the following: Dagger call minus minus working. Oops. Let me just check one thing. Sorry about that. SRC main init working there. Yeah, sure. Well, let's see. Dagger. Cool. Working there, our working directory, and then Jupyter Lab, that is the name of our function, and app. App will tell Jupyter Lab to do what it should do, so taking all the needed stuff. Let me, yeah, open Tmax. Oops. Come on. Just 1 second of patience. Okay. Source. All right. And let's bring this up. So you see that now it will start a Docker engine, a Docker container inside the Dagger engine, exposing the Jupyter Lab. So I'm importing from my working directory, importing, I'm not mounting, right? So what you do in this step is importing everything. Yeah, I suppose that. I had the impression that I was failing out, and this is because this should be like this. Oh, let's see if this is the case. Right, so Jupyter Hub now should be correct one. Yeah, talking of running inside the engine, you see that I'm not seeing anything built on the host, right? It's all it's sandboxed inside the engine, and this is the cool thing because it brings us two advantages. The first one is reproducible everywhere independently from the host or whatever, and then you have, all right, I don't know if someone in chat know what I'm doing wrong actually, but working there. Right, directory working there, Jupyter Lab working there. Let me, okay, that's no panic, no panic. Oh, let's see. Dependencies, chaining, attributes function. of name, greetings, secret services, dependencies. For just a second, hold on. We are almost there. Name overrides is not the case. Oh, I was almost string args. I was string args before. An example. Let's see. Okay, I have an idea. So I'm being potato, and we're going to spy on how it was done string args. Okay, it was with the underscore. So working underscore there, right? So it should be like this. I don't know. I don't get why. So it's not working. And here it is. Now, Dagger code working there. Right. So, right, because we have string args. Yeah. Oh. Right. Jupyter lab. Working there up. All right, was my bad. The code was right, but exactly. So here we are. To avoid this confusion, I should have simply done something like this. That is the cool stuff that you can do now with the function. You have created out of the box a command line for your function. So here it is. Your Jupyter Lab, and you can see, okay, Jupyter Lab function is waiting for token and working there. So you can do all these commands that are the commands for a service, and now we are ready to go eventually. So we're passing working directory and we're passing token. And then we pass the app command that create a tunnel that forward the traffic from the caller network to the service. All right. Now we should be, come on. Yes, and token. So the secret has this fine fact that we can pass the token secretly, quote unquote. So we can export our token in an environment variable and say, okay, task me please. And then with this syntax, you're passing the token through an environment variable, for instance. It's everything written here, so no reason to freak out. And okay, now it's starting. You see that now it's downloading the image that we asked for, and the blob of the content of the directory of our working dir is now been mounted inside the container, and we will find all the content that has been dumped into the engine. So our notebook and our inputs eventually. So let's see how it goes. And all right, enable the localhost proxy, and we should be able to look at that. So while this is charging, I have to go a step further. We are going to do we are going to do the following. Import data, but instead of doing pre-process at this stage, we are doing this other stuff. So we have import data here, and we chain two different modules, the import data and the one that we just wrote, so the Jupyter Lab. Our first exercise then is this. Create a module a Kaggle module that import data and launch a Jupyter Lab. Simple like that. Then we can implement two other functions that if we add time, we are going to do this evening. Otherwise, we are going to postpone. Doing what the Jupyter Lab is doing, but in a more specific and modular way. All right. Oh, you still there? I see some error. Yeah. All right. No, I think you're still connected. Yeah. So, all right, this is quite a big image. It's taking a while. Let me go back to 12-hour consensus. So, what is happening here now is that we're going to put a box okay, up here. I don't know why I'm getting this error. Just a second. Oh, minus D 1991. Come on. Yeah, sorry. So, right. So now you have our work in there that we will populate with this function, and it will be mounted eventually by this other function. Not only that, we are going to pass around this directory also to the second set of function. So you remember all the building blocks? The red one will be our building blocks, and we're going to chain everything together in a coherent manner. So let's get started and see. Too heavy. I don't know, 24 minutes looks like a lot. Okay. All right. We are there. Cool. So now we have eventually. We had done it. So local host 888. No, come on. Why you do me that? Why? Ooh, 0008. That's everything working. Oh. All right. Test me, please. Test me, please. Okay, so the good thing is that we are contacting that, but the secret is not correct. So what I did, Jupyter Lab token, export token, test me please. Test me please. So now you are going to see something very cool. The second part of the sentence that I didn't finish before because I got distracted is that we are going to have a cache stored inside the engine. So not only for this very same step, but for every step building a container, you have a well-managed cache that you can pass and use in different ways. So HL Now that is up and running, we should be able to log in, but we are not. Oh, 0008. I don't know, guys. So Dagger secrets. Anyone here is connected? So I knew that. I knew that I should have done that. Any help? Choose what I want to send. So okay. Ooh. Oh, disaster, man. Okay. Continue. Hello, Saga. Hope you can help. Or if you have to learn, just a second, because we are getting into trouble. Because I cannot connect to my notebook. And I lost access to the chat. That's quite a pity. All right. Login next. Token. Identity provider token. Dagger secret. Ah, I see now. Cool, this is a very important stuff that I forgot. And so, this is the cool thing of the life. You learn by failing what you should never, ever, ever forget. So, plain text equal to token dot how it's called, texter, something like that. Yeah, await token plain text. It was in the documentation. I didn't read the documentation. Please don't do the same. Okay. Plain text. Yes. And plain text now is here. Come on. Plain text. All right. And of course, since we are using await, we need an async def return await. So okay, we need to prepare the container first. Okay, and then we need exactly. So exactly. Oh no. No, it's not working. So I'll post how you can do that. You will forgive me, but we are losing too much time around this stuff. So let's get rid of this, and I pass the token directly as a string, right? So it's everything local, isn't nothing is open, so I risk nothing, more or less. All right, so we pass here now token. Too much time loser around this. It's a bit tricky to start understanding. I'm not a Dagger developer. I'm playing with that. Bear with me because we are almost there. Then we miss just a couple of more functions to chain, and for today we can call it a day, I think. And thank you. Cool. All right. All right. Now is not good because we need to put into the token task me, please. Okay. Come on, come on. Yeah. Yeah. This time is the good one. All right. I have my Jupyter lab and my task me, please. Come on. Come on. Yes. We did it eventually. So I have one open question for Dagger nodes that are expert on this. I wonder how a service can use as input a secret, because the secret need a sync and but the service cannot be async. Okay, so async def ready service return a string. So yeah, I cannot return a service in that way. All right. Well, eventually we are here. We have finally our input available and our notebook. So we can tell the notebook, cool, our data are inside. Oops. Was walk. Oops. Input. Right. Here. So take this. Take my input, and I have the complete notebook running. Cool, cool, cool. Right. So there is this one. Now we have everything eventually, so we can run whatever we want. Be aware that this will be kept inside the engine, so it just to demonstrate that you can run something. There are ways to export whatever you do inside the container, but you know that's how life goes. And more importantly, we are going to use this just as an example of chaining functions. So we have another function that we need to set up, and The first one was difficult for my fault, sorry, but the second one should be easier. So we want to access, let's say that we want to run a preliminary step on the data we have. So we want to run, for instance, and dump a new file inside this container. So what we can do, so we can do the following. We can make, all right, we can make Jupyter Lab taking a container as an input. So base container, or even better, we can define values that are stored inside the class. So for instance, here we can use lab container and say, look, this is a container entity, right? So, and then from here we can say, let's comment this and say, look, use self dot lab container as the container to start from, right? You say, okay, but why is that? Because now you can create a new function and we can tell, all right, so import new data, and again we take this, for instance, import data, and say I want to import this working directory. All right, you see what we're doing here. Doing now, here we are returning a bool, for example. We don't need anything. And working directory we remove from this. Bear with me, this is the last example for the session today. We are going to take over from here the next time. That will be next week. Sorry, I'm really sorry we lost a lot of time around some stupid thing, but you know, that's the good thing of doing life. You learn what not to do, at least. Okay, let's say we create a container with my data. And we say here self dot lab container, and we're going to do the following. Going to say take this amount, this one will be at the same situation as before, but we are chaining function. So eventually I can chain this import data with other functions that are not Jupyter Lab. I can chain this import data with something that we are going to do next time, that is function, for instance def, and we are going to do pre-process data, right? And from that parameter a string, and so on and so forth. So you can combine all of them in a chain, returning also in this case a container, for instance. Right? So we are going to implement this next. So you can decide from the command line if you want to do your analysis on in an independent way, or instead you want to do your analysis on preprocessed data, meaning import your data and launch a Jupyter Lab. The freedom of these blocks you should start to see, hopefully, at least this I want, the only message I want to pass, that you have freedom to implement steps that you can reuse. Really, this is the correct way to achieve that if you want in this context. So create different functions that you can reuse in different situations. And that's the power to me of a solution like this. Let's see in practice what I mean. So I can return true. Okay. Yeah, of course. Okay. Now, this lab container can be whatever, depending on how many functions I put on top of this. So what I'm doing is the following. I have this module here, the Jupyter Lab, that takes as input a container. Okay? A container that should be a Jupyter Lab container capable of being executed as a service. So here you have the service, JLab service, right? So this is your access point. You enter from here. But how you arrive to container, it really depends on what you do before. And before, you can do a plethora of things. You can do a simple import data module you can put, or and then go directly here. Or you can even have another module, say preprocess my data, so removing null, value, and whatever, so on. So here you have again, that's not the correct picture, it's again another container that is passed around and composed in this way. So container, 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 and eventually you can decide, okay, now I want the results of this chain to be composed via a Jupyter Lab. And you can do this from defining your function and compose them with the command line. That's what is cool about this. So now we are in this situation, right? We have implemented a very basic import data that produce a container and go to Jupyter Lab. Let's see how we can use this. Right, so we import data. And to do that, we go to the documentation, and this behavior goes under the name of chaining, right? So to chain stuff, you need to put something in the self of your class, and then a function that return self. Okay, type. Yeah, and how it works. So let's take this example. Let me zoom in. So you have with greeting that returns self, do something with the global self greeting, and then you do with the name, you have self and do something with name. and return self again. And then you have eventually message that collect everything you stored with the previous two function and return something printed. So you're going to call first thing with greeting with its options, with name with its option, and then eventually message. That's all. So let's see if we can do that. It's a challenge actually. So let's see how it goes. We want to chain import data with JupyterLab. You recall this graph? So import data container JupyterLab. Here we are. So good. You're good. Let me double check because last time I did a mess. So it's taking self lab container here and it's working. Wow. Self is not defined. I need to import some way. Typing. Okay. And of course, true is not type self, but self it is. Cool. So now, if I not get mistaken, I can do Dagger. Cool. Ouch. I don't remember. Let me see. Dagger. Cool. If I can get up from here, that would be also useful. Having a self-documented command line for combining workflows. We're doing that really basic stuff, but yeah, you can see where it's heading, right? So it's heading to something that allow you to make composable stuff reproducible, documented at command line level. So lab container -h, sorry. That it would be very cool. Yes. So it's remind us import data is the method that I was failing to recall. So okay. Okay, there is also one other thing that we need to do is to say that is a dag container. Okay, initialize the value. So Dagger call import data -- working dir working -dir working dir, and then we are chaining this with our JupyterLab token test me please whatever and bring up my service. Finger crossed. What do you think? We are failing or we are good? Let's see. Let's see how it goes. Come on. Import data. Right. Not even copy from the prompt. So, yeah. All right. Yes, it's starting. Let's see if we can connect again and see the same thing. So we are connecting. The password is the same. And yes, we have everything mounted like before. So we changed the whole thing, and what happened is we ended up with two components talking to each other. Now, where is the power of all of this? In two places. Let me conclude with this. The first one is that now we can proceed further with new function and saying, okay, preprocess data parameter A, for example, you can do something to the data and do self here, returning self, turning self. And here we can generalize saying import data can be something like self put dot lab container with mounted directory, and then we can take this, get rid of this, and do it this way. So we are copying, putting this here. So we decide that our very base image from which we start is quay image. What I just did, I don't know. Yeah. Okay. And then, so we keep the whole chain pretty cool. And then, for instance, here we can tell, all right, I want to start from self dot lab container, and again lab container dot something that is, for instance, with exec, and we're going to tell echo no, not echo, but cat, or again bash minus c yeah, double quote got me mad, but okay, bash minus c equal test into some folder that can be, for example, any other folder, test.txt of my image. All right, let's see how this goes. Yeah, we don't put test, but we put here parameter a. Parameter a equal test temp. Good. So we are now in this other situation. We start with a container that is the base one. We go to the import data, but this time we're following this other stuff. Import data is creating the data for our inputs. We do the pre-process, and then eventually the pre-process step, we create a new file that we are going to mount into Jupyter Lab. So how cool it is. And now parameter A, all good, no errors. Now we can ask again for call minus h, and while it's running, I show you something that will blow your mind. At least it did with me. That is the Daggervere. So you can publish all your function that can be general enough to be useful for any other data science pipeline, and publish this in the Daggervere. So you put this into a GitHub repository, and you can reuse everything you find there. So you find there modules written in TypeScript, Go, Python. You can take everything and import as function into your code. And vice versa, you can publish this, take again your function for all different stuff. We are going through this the next time, so if you want to be notified, please subscribe and you will be aware where the next slide will be. Yeah, so let's see for some cool modules. You can load a service again in the very same pipeline, hosting for instance a min.io server, so an object storage that you can store and retrieve data from, or you can send email whenever your pipeline is finished, for example, and so on and so forth. So you have all these methods and function, and you can use them inside your code, just like we did with our own function. And yeah, now you see that we have pre-processed data. We did not document what it does. Not good. Don't do that. But yeah, we were in a hurry. And now we can chain again our functions. So for instance, import data, working there. And then instead of going directly to the Jupyter Lab, we can say pre-process data. Be aware that we are doing this, but you can also do it programmatically. I just like to do this to show you also the command line that is very cool. Pre-processed data, and the option was parameter a. The name was what we can put. Okay, we can put hello like this. Jupyter Lab token test me. Yeah. So let's see how it goes. So we start from that container. We can put whatever we want also. Import data. Yeah. Import. That was the wrong command. So notice that here we put for lab container a default image in our code. You can also explicitly override the base image for you Jupyter Lab. So you can start from here with a default image, but you can also set whatever you want and compose and play with this command line. I think it's actually quite general that for the next time we will be able to publish something meaningful. So for instance, putting into import data the cargo import data, and for the process some very basic cleaning stuff for tabular data frames, and keeping Jupyter Lab like it is, so we can publish and have people working with this kind of chain for developing stuff. Yeah, it can be a first achievement, I'd say. So, all right, let's see what went wrong. Start bash. All right. So we are using the entry point in the wrong manner. Let me see. All right. So with exec. All right. Yeah. So we should put here with entry point, and the entry point is of args list. Yes. So let's sh or bash, it's same, and exec this, and then here we should say with default okay. With default entry point. Well, we can tell that the entry point is this one, so we can keep this. All right, almost finished. Brace yourself. We're almost there. Ooh, so tiny. Minus G and minus minus. Let's start that SH. So, oops. Where is the arrow? Oh. Okay. Let's try again. Woo! We went quite long on this, but yeah. Yeah. We are there, man. All right. No. Equal Bashman. Ooh. King of typo. Here it is. So what we did here. I don't know actually. So bash equal. Anyone has an idea? Why I choose difficult stuff every time? But okay. Maybe. Say maybe. I wonder if this should do the trick. Yeah, I suppose yes. Let's say. Good. Hope for the best. Otherwise, yeah. And otherwise, we try to summarize and draw down a plan for the next time. So we want to achieve this in the most complete part, and what we have now is the following: is basic dummy function chain. So this is what we have right now, and next time I want to do the following. I want to create actual Titanic chain and publish a cargo Dagger pipeline module. So module with the following. So import dataset, clean data, and well, we can put more. We can put pre-process commands. Okay, pre-process script, running a script that pre-processes your data, so you can start from your Jupyter lab with clean data and work on that. Also store output on Min.io service. So you can see how we can integrate different services from different places. All right, so this is what we are going to do. Let's see how it went. Kernel not found, but it's good because it's meaning that everything is up and running. Come on, we did it. We did it. And now we can see what we just put into the temp txt, and let me make it bigger. We have hello, right? So yeah, I call it a success after a long and complicated chain of errors, but yeah, so far so good. We have the basic chain of function implementation in place. We are adding right away next time to starting from where we left and implement further new stuff. So the code that we should have done today if we haven't so many issues. But yeah, I think it's also good to see people fail so you won't fail next time. So I'm concluding. Thank you everyone for watching. I see someone also connected and stay connected after 1 hour and a half. So yeah, thank you very much, and see you on the next session. And if you enjoy the stream and the way I failed out, subscribe and keep let's stay in contact. See you. Have a nice day or nice evening. Bye bye.